Hello and welcome everyone. This is Manish from Skillableindia. One of the very famous terminology which we use into our GD&T engineering drawings is a feature. Okay, so in today's session we are going to learn about feature and feature of size. In feature we will going to learn that how many types of features are there and how to recognize the feature of size. Okay, so most of the time we use this terminology without really knowing that what it really means. Okay, so we are going to discuss about feature, that what different types of features are there and what we can use into our GD&T drawings. Okay, so if I told you this definition, so feature is general term used for a physical portion of the part. Okay, so feature is a physical portion of the part, or its representation on drawing models and digital data files. Okay, so features can be any. Okay, it can be a surface can be a feature, a whole surface can be a feature, tap is a feature, fillet can be a feature, short can be a feature. So all these are the feature into the drawings. Okay, so these are considered to be the feature. The term feature is never used to describe imaginary items. Okay, so feature are not for the imaginary items. They are for the physical portion of the part. Like center line, axis, planes are not features. Okay, so these are some of the example. Now, in this image, what you can see is a rectangular block. Okay, so with this example, in this image, you can see a rectangular block with 4 holes. Okay, let's say this is a block which is having a rectangular block and which is having 6 faces of. So in this 6 faces of this block are 6 feature. Okay, so these are 6 features and 4 holes. These 4 holes are also considered as a 4 features. So 4 holes also considered as a 4 feature. Okay, so in total, if we see, there are total 10 features in this part. 10 features in this part. Okay, so this is called feature, and this is how we can find out the differentiate between the features. Okay, now we will understand the complex feature. Okay, so what is complex feature? This is the next terminology which we used. Okay, so what we have is complex feature, which is nothing but a single surface. Okay, we have a single surface of compound curvatures. Or a collection of feature. Okay, so in this example you can see that this is a flat surface, then this is a fillet, then there is a tapered surface, then there is a fillet, and then there is a flat surface. Okay, so it is combination of different features. Okay, single surface is having a compound curvature of collection of features. So in this you can see, in this there are collection of features. Sorry. Yes. Okay, so in this example we have a fillet surface. Okay, so these are all which is connected with the one another. Okay, so all the features are connected with one another. From point A to point B, collection of features can be called as single feature. Okay, so these collection of features are called as single feature. Called as single feature, and this is called as complex feature. So this is all about the complex feature. Now we are going to understand the next terminology, which is the interrupted feature. So then we have a interrupted feature, which is nothing but a feature with one gap. Okay, so in this you can see, in this feature, this is a single feature with one gap. Okay, so this is considered to be a gap that divides into two or more feature. Okay, so this gap actually divides it into two features, this surface and this surface, as individual features. So this is called the interrupted feature. In this example, you can already said we have slot. In this is a slot which divides this feature and this feature into two features. Okay, so most often these two features are considered to be two separate features. Now people started calling as a single feature, called as interrupted feature. Okay, so this is also we use as interrupted features. Now now we are going to start with a feature of size. Okay, so it is very important topic to learn in this GD&T, because again and again we are going to use this feature of size. Okay, so now we are going to discuss about the feature of size. So what feature of size is? Feature of size is a general term used to refer to either a regular feature of size or a irregular feature of size. Okay, so there are mostly two types of regular feature of size we use. If we go through the definition, so feature of size refers to any surface or set of parallel surfaces associated with the size dimension. Okay, so let's say there are parallel surfaces which are any surfaces which are associated with the dimension. Okay, parallel surfaces here seen, and any surfaces or a set of parallel surfaces associated with the dimension, specifically example include in this example. Okay, so feature of size is of two regular feature of size and irregular feature of size. Okay, irregular feature of size. What is regular feature of size? RFOS it is called. It is if a cylindrical surface or a spherical surface or a circular element or a set of two opposed parallel lines. Okay, so what are things? Cylindrical surface, spherical surface, or a circular element or a set of two opposed lines, parallel lines, element or opposed parallel surfaces associated with directly tolerance dimension. Okay, associated by directly tolerance dimension is known as regular feature of size. Okay, in this example you can see that these are two parallel lines. This line and this line are two parallel lines. This is associated with the dimension. So this is the dimension. Okay, so if this is associated with the dimension, means this is regular feature of size. Okay, this dimension is also this line and this line parallel to each other, and they are associated with the dimension which is 120. So this is also the example of RFOS. Okay, in this also this dimension, actually this dimension it is showing. So in this part, this is a circular part. Okay, cylindrical part, shaft which is having groove over here. So in this example, this is also we can check. Okay, so this is also an example of regular feature of size. So if this feature we have in this, you can see the cylindrical shaft. Okay, and it is associated with the diameter. So this is a regular feature of size. So the faces, the parallel faces are there. Okay, so groove, I have already told you that groove diameter is a circular element which is associated with the dimension. So this is groove is a circular element throughout the shaft which is associated with the dimension 20. Okay, so this is also the example of regular feature of size. Okay, so in simple layman language, if I tell you this thing, if you want to understand, so in simple layman language, if you want to understand that what a regular feature of size is, so if you take a vernier caliper, okay, if you take a vernier caliper and if you are measure any part, okay, and if you are able to measure that part with the help of vernier caliper, whatever dimension you will be measured with the help of caliper, then it is considered to be a regular feature of size. Okay, so simple layman language, if we can measure with the help of vernier caliper, we can measure with the, with vernier caliper, then the dimension is regular feature of size. Then dimension is regular feature of size. Okay. Now the second one is irregular feature of size. Okay. So in irregular feature of size also, there are two types of irregular feature of size. First one is type A and second one is type B. When it comes to the irregular feature of size, I have already told you, which is nothing but in this, if we go with the definition, so this nothing but a directly tolerance feature. It is a directly tolerance feature or collection of feature. Okay. So basically, the directly tolerance feature or a collection of feature which that may contain or to be contained by unrelated actual meeting envelope. That is a cylindrical or sphere or two parallel opposed parallel planes. Okay. So in this, what this definition is showing, let's say if I want to check this dimension from this point to here. Okay. So it is not possible to check with the help of vernier caliper. So this dimension we cannot measure with the help of vernier caliper. So for that, what we have to do is we have to create one unrelated actual meeting envelope. What is this actual unrelated meeting envelope? We will discuss in the further session. Okay, but it is an let's say this is a this envelope we have created. Okay, the above that part and the below this part. So now we are able to measure this part from this distance from here to over here with the help of vernier caliper. Okay. So now by creating this actual meeting envelope and related actual meeting envelope, we are able to check the part with the help of vernier caliper. So that's why this is the irregular feature of size. Okay. And this is very, very important, that how to create a actual meeting envelope. We will understand in the near sessions. So you can see this collection of features which are associated with the dimensions. Okay. So this feature is associated with the dimension and this feature is associated with the dimension. So after creating the actual meeting envelope, the height, we can measure the height of this part with the help of vernier caliper. So such objects are called the irregular feature of size type A. So this is called the type A, irregular feature of size. Now the second type is type B. Okay. So irregular feature of size type B, what does this says? It is directly tolerance feature or collection of feature that may contain or to be contained unrelated actual meeting envelope. That is other than the cylindrical sphere or two opposed parallel lines. Okay. So other than the cylindrical sphere and two opposed parallel lines. In the type A, you can see in type A, these are two parallel opposed lines. So in type A, if I will, in type A, only the opposite parallel lines, in this case, these are the opposite parallel lines, or the surfaces should be cylindrical in nature. Okay. Cylindrical or sphere or two opposed parallel lines. If these three conditions are to be satisfied, then it is into the type A, and it is and the dimensions cannot be measured with the help of vernier caliper. Then it is into the type A. If the part in other than the cylindrical or sphere or two opposed parallel lines or cannot measure with the help of vernier caliper, then it is considered to be the type B. Okay. So now it is considered to be the type B. So in this case, you can see the part is having a groove inside this a groove which is in triangle in nature. So it is not a cylindrical nor a sphere or not two opposed lines. Okay. So this is a triangular surface. Okay. So now we have to create a actual meeting envelope. In this case, this is we have created, which is exactly that shape. So in this example, we can have a triangle. I have already told you. To measure this triangle, we require an envelope. Okay. This envelope to counter shape of a triangle itself. Okay. So this is, we have created an counter shape envelope. Counter shape envelope. Okay. This counter shape envelope of a triangle itself. So this shape is not a cylindrical shape, nor this is not a cylindrical shape, nor a spherical shape, or nor a two opposed parallel planes. Okay. So hence this is called the type B irregular feature of size. Okay. So this is very, very important that if I will summarize all this in one go. Okay. So what is the regular feature of size? First of all, what is the feature of size? So feature of size, any dimension which we can measure for the features onto the part. Okay. Then feature of size is particularly divided into two: regular feature of size and irregular feature of size. So what is a regular feature of size? A regular feature of size is a size which we can measure with the help of vernier caliper easily, whether it's two parallel opposed surfaces, or let's say any hole is there, any other dimension which we can measure with the help of the vernier caliper. It is into the regular feature of size. Then the second part is irregular feature of size. In irregular feature of size, we have two types: type A irregular feature of size and type B irregular feature of size. In type A irregular feature of size, we have to create a unrelated actual meeting envelope. Okay, so in type A, we can only check cylindrical surfaces, spherical surfaces, and the two opposed parallel planes. That is considered to be into the type A. Okay, and irregular feature of size cannot be measured with the help of vernier caliper. That's why we have to create an envelope in such a way that after that we can measure the dimension with the help of vernier caliper. Okay. In the irregular feature of size type B, what we do, we create other than the spherical or cylindrical or two opposed planes, let's say there is a triangular or any hexagonal shape. Okay, so for that we create a counter shape envelope. Okay, so in this I have already told you, in this triangular shape we have created a counter shape envelope to measure the to check the or measure the part. Okay. So this is the type B irregular feature of size. So this is all about the topic. In the next topic, we are going to discuss about the actual meeting envelopes. Thank you. Thanks a lot.